Assalamu alaikum and hello everybody, welcome to Maths Able. Today we will be doing differentiation, so let's get started. In differentiation we differentiate y or any curve's equation or any quadratic function's equation into dy over dx. Dy over dx is a notation also called the Leibniz's notation, who was the co-founder of calculus alongside Sir Isaac Newton. Although we won't be studying the complexity of differentiations, you just need to know the basics. So dy over dx is the rate of change of a function with respect to a variable. It's also known as a slope or the gradient graphically of any quadratic function or curve. You can also name it y dash. So let's say we have an equation y is equal to x to the power of n. While differentiating, we multiply the coefficient of a variable, in this case it's x, by the power of x, so n. So now we'll be left with nx. And after multiplying the coefficient, you reduce the power by 1. So now let's carry out with some examples. Here we have an equation of a curve, a quadratic equation. So if we differentiate for x squared, we multiply the coefficient by 2, hence it x power 1, because you reduced the power of the x by 1, plus here the power of x is 1, so 1 times 3 gives you 3, and 1 minus 1 is 0, so we're left with the power 0. So anything to the power of 0 gives you 1, so 3 times 1 is 3 itself, so x is gone. And in any case, when you have a constant number, in this case it is 7 with no x or any variable, that is equal to 0. So dy over dx, or the gradient you can say, or y dash, is equal to 8x plus 3. Now let's practice another case in which the equation of almost more than half of the equation of the curve is inside brackets, hence inner derivations. So there is a coefficient outside the brackets and there is a whole power minus 5. In this case, you first multiply the coefficient by the whole power, hence minus 5, hence giving you minus 10. The inner terms remain the same, so 3x squared plus 1 whole power decreases, so minus 6, and then you multiply the derivation of the inner terms, so 3x squared gives you 6x, and plus 1 is a lone constant giving you 0, so 6x. Whenever there is a negative whole power, you simplify it and bring it to the denominator. So minus 10 times 6x divided by 3x squared plus 1 whole power positive 6, which is equal to minus 60x divided by 3x squared plus 1 whole power 6. Now let's move on to our third case, in which they can ask you for the gradient of a curve and give you the point, any point on the curve. In this case, when you differentiate y is equal to 2x cubed, you get dy by dx is equal to 6x squared. Now dy by dx is also known as the gradient, so m gradient is equal to 6x squared. Substituting the value of x, which is 3, in the place of x, gives you 3 squared, which is 9. So 9 times 6 gives you 54, which is our gradient. Moving on to our fourth case, where they can ask you for the double derivative. It is also the nature of a curve. So if they can ever ask you for the nature, if whether it's a maximum or a minimum point on the curve, you can take out the double derivative. If the value is positive, it is a minima. If the value is negative, it's a maximum. Hence, a negative or a positive parabola. So in this case, the derivative of 4x squared plus 3x gives you 8x plus 3. And the double derivative of the following gives you 8. As x's power is 1, 1 minus 1 gives you 0, x power 0, 1, so 1 times 8 is 8, and the lone constant 3 is equal to 0, so 8 plus 0, 8. Moving on to our fifth and final case, in which there are questions on rates of change of derivatives. In this case, an ice cube melts uniformly at a rate of 27 centimeter cube per second. If the cube retains its perfect form while melting, at what rate are the sides shrinking when each side is 3 centimeters long? So the information we have here is that x is equal to 3 centimeters, and it melts at a rate of 27 cm cube per second. Hence, the rate of change of volume per unit time is negative 27. So dv per unit time, so dt over dt is equal to negative 27 centimeters cube per second. And we need to find dx over dt. So the rate of change of the length of each side per unit time is equal to question mark. Now we can say that the volume is equal to x cube, hence dv over dt is equal to 3x square, which is its derivation, dx by dt. You can also use the chain rule, which can be used in other questions as well. Hence dy over dx is equal to dy by dt times dt by dx, as the per unit time dt gets cancelled on both sides. So in this case, if you multiply both sides by 1 over 3x square, it gets cancelled, and this side is also multiplied by 3x square, giving us 1 over 3x square times dv by dt is equal to dx over dt. And now dx over dt is equal to 1 over 3x 3x squared times the dv over dt. So dx over dt, if we put the value of x, so it gives us 3 times 3 whole square. So dx over dt is equal to 1 over 3 times 3 square, which is 27. So 9 times 3, 27. 1 over 27 times minus 27, as that is the rate of change of volume. So 1 over 27 times minus 27, hence the rate of change of volume. So dx over dt would be equal to minus 1 centimeters per second, as minus 27 27 get cancelled. So dx over dt is equal to minus 1 centimeters per second. Now that will be it for the chapter differentiations. Hopefully you understood all the new concepts. So now have a great rest of your day, and assalamu alaikum.